Welcome to today's lesson on abstraction in programming languages. In this presentation, we will cover data abstraction, function abstraction, encapsulation, and polymorphism, all of which are essential concepts in object-oriented programming. Let's start with an overview of abstraction. Abstraction is the process of simplifying complex systems by focusing on the essential details while hiding unnecessary information. The main goal of abstraction is to reduce complexity, making it easier to understand and work with software systems. Data abstraction is about hiding the implementation details of data structures and exposing only the necessary aspects. For instance, in C++, we can use abstract classes to define a common interface for different data types, while the underlying details remain hidden. This allows us to interact with objects in a simplified manner without needing to understand the internal workings. Function abstraction follows a similar principle but focuses on functions or methods. We hide the complexity of the function's implementation, presenting only the interface that users need to interact with. For example, Python's built-in sum function allows us to add numbers without worrying about how the function processes them internally. Encapsulation is the practice of bundling data and methods that operate on that data into a single unit or class. This not only improves organization but also restricts access to the data, preventing unintended manipulation. In Java, we achieve this by making data fields private and providing public methods to access and modify them, ensuring that data is accessed in a controlled manner. Information hiding is an integral part of encapsulation. It involves restricting access to certain details of an object and only exposing the necessary parts. For example, in Java, we make fields private and provide public getter and setter methods, which ensures that external code cannot directly alter the object's internal state. Polymorphism in object-oriented programming allows objects of different types to respond to the same method call in their own unique way. This makes our code more flexible and reusable. Polymorphism comes in two forms: method overloading, where multiple methods share the same name but differ in parameters, and method overriding, where a subclass provides its own version of a method defined in the superclass. Abstraction and polymorphism go hand in hand in object-oriented programming. Abstraction hides the implementation details, while polymorphism allows different objects to respond to the same interface in different ways. This combination makes our code more adaptable and maintainable. We, as we can add new objects or modify existing ones without changing the interface that other parts of the system rely on. Now let's look at the key benefits of abstraction. First, it simplifies the design by hiding unnecessary details. It also makes our code more maintainable as internal changes don't affect the user interface. Abstraction promotes code reusability, allowing us to use common operations across different parts of our system, and increases flexibility by enabling us to evolve the system without breaking existing functionality. To summarize, abstraction helps manage complexity by hiding irrelevant details and focusing on the essential. Data and function abstraction simplify the way we handle data and operations, while encapsulation protects data. Polymorphism makes our code more flexible and reusable, and all these concepts are fundamental in object-oriented programming, leading to modular, maintainable systems. That concludes the presentation. Do you have any questions, or would you like further clarification on any of the concepts we discussed today?